6.9, the quadratic formula. This is the fifth and final way you will learn how to solve a quadratic equation. This one can always be used. There's never a time you can't use it. Factoring, you can only use sometimes. Sometimes a problem doesn't factor, so then you might automatically say it's no solution even though it's not. This one will always work out. Square roots also is not something it has to have where there's not a b value in order for you to be able to work through it using square roots. Graphing can be tedious, and that's why this one is usually turned to, because it will always work. In this, you have to memorize the quadratic formula. Normally, if we were in the classroom, I do like a cutesy little oral quiz and I have you go around the room. It's kind of fun, kind of not, but it is fun for me at least to sit there and quiz you on the quadratic formula. Now, so you don't get beat up on the streets and you say it properly and you don't embarrass me of where you learn the quadratic formula, I want you to be able to say it properly. So the correct way to say it out loud verbally is that x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, I highlighted the opposite of b because you don't want to say negative b, because if b ends up being negative, it actually turns around and becomes positive because the negative sign is already there. So if by saying the opposite of b, if b is positive, it becomes negative. But if b is negative already, then it's going to become positive. So it's better for you to say that it's the opposite of b rather than negative b. If you get stuck up on that, it can get a little confusing. Now, as I was already stating, quadratic formula works on every single quadratic equation. It will always work. However, you first have to get the equation so that it is equal to 0, so that you can derive or you can get out what the a value, the b value, and the c value is out of the equation. So let's do some examples. In the first example, my a value is 2, my b value is 3, and your c value, make sure you take into consideration that negative, is -5. So whatever net signs are in front of those numbers, you want to use as well. So we're going to plug this into the quadratic formula. X equals the opposite of b. So I'm just going to put parentheses around the stuff as I'm plugging it in, just so you can see where everything is going into place. When quiz time comes around, you will not have the quadratic formula given to you anywhere on any sort of quiz. It's not even given on the SATs or anything like that. So it is something, that's the one catch. It's not a difficult formula to use. It's just you have to have it memorized. Now, at this point, I plugged in all my A, my B, and my C into the equation. Technically, you can type this all into your calculator. You have to be very, very, very careful with the parentheses. What I would highly recommend you do, instead of at this stage typing in a calculator, clean it up a bit. Some of this math can be easily done in your head, such as making that negative sign, making the 3 negative, plus or minus. 3 squared is 9. Then I have minus -40. 4 times 2 is 8. 8 times -5, that gave me a -40. 2 times 2 is 4. I can still clean this up a little bit. And I have 9 plus 40, because the minus and negative becomes positive 40. And this is still going to get cleaned up, plus or minus the square root of 49 divided by 4, which is, I can still do this in my head. Square root of 49 is 7 divided by 4. In addition to typing and being very careful with your parentheses, when you're typing in a calculator, there is no plus or minus sign on the calculator. So you would have to do one with the plus version and then one with the minus version. That is a very intricate formula to type into your calculator. It is much easier to get it down to the point where now you can separate it. And I have -3 minus 7 divided by 4, and simplify. This is going to give me 4 over 4. This is going to give me -10 over 4. Which I'm going to further simplify, and that's going to become 1 and -5 over 2. And that would be my answer. You can check your answer by plugging the equation into your calculator and making sure that both of them you end up getting 0 as your answer. Now I'm going to scoot this one down because I didn't have enough room, or I used up too much room for the second example. Okay, in this second example, I'm still going to run out of room. In the second example, I need to rearrange this so that I have everything over to one side. So I'm going to bring over the 2x. So now I have 0 equals x squared minus 2x minus 3. My a value is 1, my b value is negative 2, my c value is negative 3. So now I'm going to type everything in, or put everything into the equation. X equals the opposite of b, which would be negative 2, plus or minus, I'm going to have negative 2 squared minus 4 times 1 times negative 3. All over 2 times 1. This is going to give me 2 plus or minus the square root of 4 plus 12, all divided by 2, which gives me 2 plus or minus the square root of 16 over 2, which becomes 2 plus or minus 4, all divided by 2. That's going to split up into 2 plus 4 divided by 2 and 2 minus 4 divided by 2, which will give me, in simplified form, the first one becomes 6 over 2, which is 3, and the second one is negative 2 over 2, which would be negative 1. So my answer here would be 3 and negative 1. Okay, now, in this particular problem, the only thing that's different on this one is the fact that your a value ends up being negative. And that's totally fine. Just take that in consideration when you go to plug it into the quadratic formula. So in this one, my a value is negative 3, b is 5, and c is 2. So I have x equals the opposite of b plus or minus b squared minus 4 times negative 3 times 2. 4 times a times c, all divided by 2 times a. All right, I'm going to clean this up. So I have x equals negative 5 plus or minus the square root of 25. Because there's a double negative, it's going to become positive, and that is 24. 4 times 3 times 2 is 24, divided by negative 6. X equals negative 5 plus or minus the square root of 49 over negative 6. X equals negative 5 plus or minus 7, all divided by negative 6. And then split this up, one being plus and the other one being minus. And then you can simplify from here. This one would be 2 over negative 6, which is negative 1/3. This one would be negative 12 over negative 6, which is positive 2. So your answer is negative 1/3 and positive 2. All right, we have another one where we have to rearrange a little bit. The only thing I have to do here is I need to add 18 on both sides. So I have 2x squared plus 12x plus 18 equals 0. You always want it to equal 0 before you start plugging it into the quadratic formula. So I have a equals 2, b equals 12, c equals 18. Now, those numbers shouldn't be that big to you. However, they are larger than some of the numbers that we've done before. 2, 12, and 18 all have a GCF of 2. So if you wanted to, at the beginning, you could factor out the GCF of 2 to make your numbers smaller. And then from there, plug in your A, B, and C values, which would be 1, 6, and 9. And you would get the exact same answers. Again, it's a personal preference. It happens to be if you see it before you do the problem. It all depends. So in this one, I'm just going to continue using the 2, the 12, and the 18. Plus, you have a calculator, so the bigger numbers shouldn't be that scary as far as plugging them in and doing the math that way. So I have x equals the opposite of b plus or minus b squared minus 4 times a times c. all divided by 2 times 2. So I have x equals negative 12 plus or minus the square root of 144 minus whatever 18 times 8 is, 144 divided by 4. So x equals negative 12 plus or minus the square root of 0 over 4. X equals negative 12 plus or minus 0 over 4. Whether you add 0 or subtract 0, you're going to get the same exact answer. So this particular one is unique in the sense that what was underneath the square root sign was 0. So that basically went away, and in this circumstance, you will always end up with one answer. All right, our next one is set up. We don't have to move anything around. A is 1, B is 3, C is negative 7. So I have x equals the opposite of b plus or minus the square root of b squared minus 4 times a, which is 1, c, which is negative 7, all divided by 2 times 1. X equals negative 3 plus or minus, let's see, 9 plus 28 divided by 2. X equals negative 3 plus or minus, 37 divided by 2. Now, as you can see, 37 does not have a perfect square. It is not a perfect square. In this circumstance, this is where we're going to start getting decimal answers. So at this point, you'd be typing this into your calculator to get a decimal answer. The catch is, if for some reason they ask you for an exact answer. These two answers that I have right here, negative 3 plus the square root of 37 over 2 and negative 3 minus the square root of 37 over 2, which can be written just like it is right above. These are considered to be exact answers because nothing is being rounded. However, when they ask you to round, you are going to have to type that into your calculator. So I'm going to go ahead and do that. Let's see, divided by 37. Again, you need to be careful when entering this in your calculator. If you do it all in one step, you do need to put parentheses around this. Parentheses will show up inside the square root sign. So you have to close those off. So it's almost 4 sets if you were going to type it all in one step. I recommend 2 steps. Do the top, press enter, and then divide by 2. That way you don't have to be worrying about parentheses. Did you put enough? Did you not put enough? And I'm going to round this to the hundredths place. That's pretty much the standard to be able to round it to the hundredths place. Okay, this next one, negative 3 plus the square root of 37. Enter, divided by 2. Oh, I did plus again. I did the plus, same thing. Divided by 2, and I get negative 4.54. So my answer is 1.54 and negative 4.54. Now, when you go to check this, if you were somebody who checks your answers, if you went back and plugged in 1.54 and negative 4.54, you're going to get very close to 0 because those are rounded answers. You're not going to get exactly 0 because they're rounded. The only way you would do that is if you plugged in those exact answers. And this last example we're going to do, we have another unique situation for this one. First of all, I'm going to move over the 4. There's nothing really unique about that. It's the end that ends up being unique. Here, I have A equals 5, B equals 3, and C equals 4. So I have X equals the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So I have negative 3 plus or minus 9 minus 80, all over 10. Negative 3 plus or minus negative 71, there's the problem. This can't happen. You can't have the square root of a negative number. Therefore, you shut this problem down and you write no solution as your answer.